now that we have discussed to some extent the law of conservation of momentum and what happens in collisions and the different kinds of collisions that are possible, let us try to see if we can do some numerical analysis in this, that is numerical problem solving. Because in a way, when you are able to solve numerical problems, that's when you know if you have properly understood the concept or not. If you are not able to tackle numerical problems, then then the kinds of issues that come in that points to the fact that you might not have got the concept correctly. Then you can relearn the concept or look up that part of the concept that you don't understand. So let's take one problem, that is question 28 from plug and chug from the textbook. Conceptual physics. Okay, and the problem statement is, I'll read it out. A 3 kilogram blob of putty moving at 10 meters per second hits a 2 kilogram blob of putty at rest. Calculate the speed of the stuck together blobs of putty immediately after the collision. Okay, so remember the numbers. So first thing in numerical problem solving is always try to imagine the situation. Okay, so the way I do it is by making a drawing of it. So there is a first thing is, it's a blob of putty. So if you don't know what a putty blob is, basically it's like clay, and putty is used in construction to kind of mask some areas. Sometimes when we fix windows onto window panes, we use putty. In our school, we use putty for that purpose. Of course, you can also use it for playing and so on. But that's what a putty is. Basically, it's like unbaked clay. So there is a 3 kilogram blob of putty which is moving at a velocity of, what is the velocity?
10 meters per second.
10 meters per second. Okay, and this blob of putty runs into another blob of putty which is stationary, which is 2 kilograms, and its velocity is 0 meters per second. Okay, so this is the information that has been given to us. So what will happen afterwards, if you want to show it, is that the bigger blob of putty gets stuck with the smaller blob of putty, and they both have some velocity with which they are moving. So we have to find out what is that velocity v prime. Okay, so is the situation clear what we are talking about?
Yeah, sir.
Yes,
Yes, sir.
sir.
Yeah.
This
Yeah,
is the basically you can use the bowling ball concept, no, double the mass, half the velocity.
exactly. But in this case, it's not double because this is 3 kilograms and this is 2
Oh,
kilograms.
yeah.
Okay,
Yes.
so let us label them. The next good idea is to kind of
Put
label.
them A and B. Yeah.
So you say this is M1, this is M2, this is V1, and this is V2. Okay, and this will be V prime and this will be M prime. So there is an M prime also involved over there. How much is M prime, by the way?
M1 times M2.
N1 times
5
M2
kg.
or
One
You have
plus
to add, right?
M1
50 kgs.
plus
I mean 5 kgs.
5 kgs.
5 kg. Okay, so now I think with all that information, we should be able to tackle it. The principle that is involved over here is any kind of a collision, what will happen is momentum is going to be conserved. Okay, we are assuming that the floor is frictionless, and for
Yeah.
that short duration when the collision occurs, the friction can be ignored. So what type of collision is this when a putty sort of runs into another?
Inelastic.
Inelastic collision. Okay,
Yeah.
very good. Okay, and we can also state that, sorry, not delta P, P is equal to P prime. So whatever collision before, it will be the same as the collision afterwards. So to write our equation, it will be M1 V1 plus, make the statement. This is before P. What will it be?
M2 V2.
M2 V2.
M2 V2 will be
Mhm.
equal to, this is your P prime,
Yeah, M1 M prime V prime.
M prime and V prime. Okay. Now all the numbers are there, the equation is there, start substituting. So what is M1
3 kgs.
times what is V1
10.
10.
plus what is M2
2.
and what is V2
0.
0.
should be equal to what is M prime
5.
times what is V prime unknown.
We don't know. Yeah.
Yeah. So now you are in 8th standard, so you must have seen how to solve algebraic equation. This has come in the form of an algebraic equation, one equation with one unknown. So is this solvable?
Yeah.
Yeah.
Okay, so now please individually solve this and send me the chat message of what the answer is, and then we will discuss it afterwards.
So how did you come up with the unit?
How do you come up with the unit? Okay, I'll tell you about that. So 3 times 10 is 30 plus 2 times 0 will be 0 equals 5 V prime. So I'll exchange the LHS and the RHS over here. I'll say 5 V prime is equal to 30. So V prime is equal to 30 by 5, that is equal to 6. So the units you can come up in either of these two ways. You can say that since we are trying to find out velocity, right, and all the
velocity
velocities
unit,
are in
yeah.
SI units, it's kilograms meters per second, so no issues over here. So the answer must also be in meters per second. Or if you are interested to understand why the answer will always be in meters per second, you can look at it like this. This is momentum, so it will be kg meters per second, kg meters per second. Okay, and this is 5 V prime, so this 5 is kg, right? I'm just writing down the units. So if you look at it, V prime is equal to 30, which is, sorry, I'll missed that, kg meters per second divided by 5, which is kg. Okay, so kg and kg divide out, so V prime will come in meters per second. So that is another way in which you can know what is the units for the answer. So I hope that makes it clear. Now you can.
Isn't kg meters per seconds newtons?
Kg, no, kg
Oh, you've cut it. Okay.
square is newtons. Okay, so question number 29 up to 38 is all plug and chug, got to do with conservation of momentum. So you should be able to solve those problems. If you have any doubts or questions, please raise it to me.
So it's
All right, now let's look at question 29, which has got to do with impulse. Okay, the question is, Bowling Barry asks how much impulse is needed to stop a 10 kg bowling ball moving at 6 meters per second. So what's your answer? So every situation for me is a situation which requires some imagination. Okay, so here is a bowling ball. Okay, and its mass is equal to, there is no collision involved over here, so I won't keep it m1 m2 and all that. There is only one mass involved, so mass is equal to 10 kilograms, and the velocity of the bowling ball is v is equal to 6 meters per second. So basically what is being asked is, if you need to stop this bowling ball, you have to apply a force on it, and you have to apply the force for a certain period of time, right? Impulse is the question. So impulse we know is ft, and that is equal to change in momentum delta mv. So the thing is that is being asked is how much impulse you require to stop the bowling ball. Okay,
Oh, so the change is 60 minus 0.
sorry, yeah, make it into 0 exactly. So now to tackle that question, Ft is equal to delta mv. That means it is I'll put it as mv2 minus mv1. So I need to keep this as v1 because that's the initial velocity, right? And at the end of this process, what will happen is the bowling ball comes to a rest. Okay, so v2 will be equal to 0 meters per second when the force has been applied. So I can keep Ft equals m times v2 minus v1. Okay, so mass is 10 kilograms. v2 minus v1 is v2 is 0 and v1 is 6 meters per second. Okay, I leave out the meters per second because it's velocity. You should be able to figure that out. So if Ft is equal to 10 times 0 minus 6, then what is Ft equal to? So one equation, one unknown, you should be able to solve this. Now solve that and send the answer again by chat, and then we will discuss the final solution. Okay, one clue to everybody who is trying to solve this and not understanding something. What is 0 minus 6?
-6.
-6.
Yeah, so please keep that in mind. So obviously now the answer is minus 60, but then what are the units? Okay, so one simple thing is impulse is force multiplied by time, right? Ft means F dot T or F multiplied by T. Force is in SI, it's measured in newtons, and time is measured in seconds. So the units for this will be Newton seconds. Newton dot second, n in capital, s in small case. Now what does this mean? Okay, so this is the confusion. So Newton second doesn't seem to be meaningful. And then why the negative sign? So the negative sign is obvious because the ball is moving in this direction. So if you say this is your forward direction, आगे, right? Then everything that acts in the opposite direction will be negative. So the force has to act in the opposite direction in order to stop it. So that is what it means, that the impulse is against the direction of the motion of the object. Okay, so that is why the negative sign comes there. So it makes complete sense. Now, what does Newton second mean? The thing is, how much force are you actually going to apply in order to stop the ball? So you can say that that information is not clear in this answer, and you can have multiple interpretations. So you can apply a force of minus 60 newtons for 1 second. That will stop the ball. What other possibilities are there now? You tell me. Whole number of possibilities.
Minus 10 newtons for 6 seconds.
For 6 seconds, that is also possible. That will also stop the ball.
We just have to find the factors of it.
Yeah, more possibilities, whole number possibilities.
Minus 30
Minus 30 newtons into, yeah,
Minus
2
30
seconds.
newtons for 2 seconds. Minus 20 newtons times how many seconds?
3.
3 seconds. So all of these are possibilities. Absolutely no issue about it. You do whatever you want to stop the ball. Okay, it depends upon how much maximum force you can apply and for how long you apply. But no matter how you do it in any one of these means, you will still get an impulse of minus 60 Newton seconds. So that's what the Newton seconds unit means. I hope that is clear now. Yeah, so with those two example problems, I hope you will be able to solve the other problems that are there in the textbook and any other problem involving the law of conservation of momentum. Don't forget to hit the like button, it helps. Do consider subscribing to my channel and share the video with anybody who you think might benefit from watching this video. So until next time, see you.